conversion. Now, in Google Classroom, you do have a couple of additional resources that can help make the conversions a little bit easier. One of those tools is currently on the screen, and it is at the moment only in Google Classroom. I'm fairly confident that I put it in there for y'all. Yes, I did. In addition to the mole map, you also have a PDF that has some extra videos. So those are other highly recommended videos by topic. And then you have the information about significant figures. So there are two additional SigFig videos on top of what you should have saw on Friday. And yes, I'm going to say SigFigs probably for the rest of the time instead of significant figures. So our mole map can help us set up conversions. So if you know that you and unit analysis did not get along in math, you might want to learn how to use the mole map. If you know that you and unit analysis did get along, then don't use it. All you need is this. Technically, all we need to do most of our conversions in chemistry are the things that are in the blue box. But here's how you would use the map if you choose to use it. So you got to read the problem. And as you're reading the problem, you're going to mark your beginning and ending points. So my last problem that I just did as part of my revisit was we started with particles and we went to moles. So I would mark the map. The number of lines, the number of bridges tells me how many fractions my conversion is going to need. So notice there's literally only one bridge, one path between moles and particles. So that means we're going to need one fraction. When you go to set up the conversion, the island you are on always goes on the bottom of the fraction, and the island you are going to always goes on the top. We fill in the numbers from the equality. So the numbers would come from Avogadro's number in 1 mole. This comes in more handy or more useful as we start adding conversions to our calculations. So today we're going to be adding second conversions, where we're going to go from example to moles, from moles to mass. So we would have to do this whole thing as one big conversion. It would be 2 fractions, hence 2 steps. So you're going to see me use the mole map a little bit today, and I know it's in some of my other lessons. If you don't like it, don't use it. Simple as that. You can literally do every single conversion we have to do in chemistry with that. But I do know how challenging this topic can be for some students. Hence why I'm saying up front, use the mole map. Now, the cool thing is I could technically take all of these conversions and I could make my own fraction cards. These are the only fractions that you're allowed to write. We will see one more tomorrow. But for today, we're looking at these are the only 6 things that can be in my conversions. Now, notice the molar mass doesn't have a number. So anytime grams is used in a calculation or in a conversion, you're going to have to find molar mass. You're going to have an extra step built in. And for now, I am asking you to please continue to show your molar mass calculations. So 2-step conversions. This is very, very similar to what y'all would have saw on Friday. We're only allowed to use the 3 possible equalities. So the 1 mole in 22.4 liters, 1 mole in Avogadro's number, and 1 mole in molar mass. So Avogadro's number, there are a couple of different words that you could see with it. So you could see particles. You could also see atoms. Formula units are molecules. Atoms are used only with elements. Formula units are used only with ionic compounds, and molecules are only used with covalent compounds. And particles is any of them. So I sometimes say particles. sometimes say molecules. They are interchangeable. It's like, my name is Samuel and I go by Sam. Still the same person. So STP. STP stands for standard temperature and pressure. Until we get to gas laws, which isn't until Unit 5, we are going to make the assumption that any of our conversions are at STP, that they are occurring at standard temperature and pressure. Because if they do occur at standard temperature and pressure, this are the values that we use. Unfortunately, in a real world situation, not everything happens at ideal situations, which means if we change the temperature or we change the pressure, we're not going to have 22.4 liters. But for our purposes right now, anytime you see the phrase standard temperature and pressure, standard pressure, or STP, just know that it's giving you a little extra information. And that little extra information is only relevant if you're actually doing an experiment in a lab, actually trying to make something else. But for now, if I'm telling you find the volume of something, we're going to make the assumption that it is at standard temperature and pressure because we don't know how to change these numbers to adapt for different temperatures and different pressures. So, for example, let's say I wanted to go from grams to liters. If I wanted to go from grams to liters, I would have to use the third and the first equality to do that conversion. If I wanted to go from particles to grams, for example, if I wanted to go from particles to grams, I would have to use the second and the third one. The nice thing about the calculators is they can handle multiple calculations entered at one time. Now, the numbers in the prompt will determine what units go where in the fractions. So whatever we are starting with in the problem, whatever has that number, that's going to guide us in how we set up all of our conversions. But just like one step, two steps, basically the same thing. Write the number, unit, and formula, multiply by a fraction. We set it up so that the units cancel. So what we're getting rid of always goes on bottom. And what I'm going to goes on top. We plug in the numbers from our equalities. So again, 22.4, 1, Avogadro's number, or whatever my calculated molar mass is. Check to see if you've got the desired unit. Today we won't. So we're going to have to rinse and repeat step 2 and 3. Once we get the desired unit we want, we type it into the calculator and it will give us the mathematical answer to that calculation. We write the answer with the final units and the chemical formula. So the only difference from what we saw Friday and what we saw at the end of Unit 2 was that we are going to be repeating steps 2 and 3 more than one time. Dramatic pause. The flippin' flapjacks. Okay. So let's actually see this in action. Again, I'm going to show you how to do it with the MOMAP and without, kind of showing you how to utilize a new resource. But here's my problem number 1. Remember, it does not matter where the number is in the problem. We always have to start with that number. And for my examples in this presentation, they are using the real periodic table. So my examples are using the real periodic table. But notice we are starting with liters. Liters is the thing that has the number. So I mark that as my starting point, and my ending point is particles. We are not crossing the mole ratio bridge because we're keeping the substance the same. So for right now, we're staying on the left side of the map. Notice I've got a bridge and a bridge. So those black and red lines are my bridges. That helps me know that, hey, this is a two-step conversion. So we're going to set up our conversion. The first thing that we got to write is the number from the prompt. I know it's going to pop up again in just a second. I don't want to have to erase it. So we're going to put it here. 0.0534 liters of CO2. So 0.534 liters. Since liters is what we started with, liters must go on the bottom of the conversion. If I was using my map, my little puppy is currently on liters, so liters has to go on bottom, and the puppy's trying to get to mole, so mole has to go on top. Liters is on bottom, 22.4 must go with it. Mole is on top. This equality tells me that it's 1 mole. So we look at our units. We don't want moles, we want particles. So that means we need to do another conversion. So pretend my little puppy or my little smiley face, I'm now here on Mole Island. That's a really sad looking smiley face, but starting with moles, so moles must go on bottom. I'm going to particles, so particles goes on top. Since it is moles and particles, I'm using these numbers. So it's got to be 1 mole and Avogadro's number of particles. I look at my units now. Moles is canceled by moles, and we are left with particles. Since that gives me what the problem asks for, that means this is typed up and set up correctly. There's a nice pretty version. Oh, crap sauce. That, of course, I drew a line through. So how should my answer look? How many significant figures? Well, when we're counting significant figures, we start at the first non-zero digit. Leading zeros are not significant. They are called placeholders. So my first non-zero digit is a 5. The next ones are non-zero numbers. So this has 3 sig figs, which means even though my calculator is going to give me way more than 3 significant figures, oops, I want to type in only 3 times 6.02 times 10 to the 23rd. So calculator gives you 1.435125 times 10 to the 21st. The 10 to the 21st does need to be written, but it does not affect significant figures. That's supposed to be a 1, not a 4. So I keep the first 3 non-zero digits. The first 3 non-zero digits, and I look at the 4th one. Since that is a 5, how do we have to round? Do we round up or do we stay the same? Let it rest or raise the score? So 5 or more, raise the score. 4 or less, let it rest. So since that is a 5 or more, that's telling me that, hey, I got to round that 3 to a 4. 1.44 times 10 to the 21st. Particles of CO2. I got to put the close on the number. If it doesn't have its units and its chemical formula, it is running around butt naked. And we do not like naked numbers in chemistry. So 4 or less, let it rest. 5 or more, raise the score. You're never going to round more than once. So like even if there was another number behind the 5 that said I needed to round the 5 up, I don't look at it. I only look at the digit right next door to the last one that I know I want to keep. And yes, I know we're doing 2 skills at one time. So notice, if I had my fractions, I could fairly easily set them up and use the cards to determine that, hey, I had to use that blue one on top and the green one on the right. And that set up the conversion. And no, you don't have to show all that. Strangle a child. I'm sorry. All right, example number 2. I've got 55.6 grams of propane. How many liters do we have? Since we see that we have grams in the prompt, we know that we're going to be using this third conversion, which means that, yes, we're going to have to find molar mass. Additionally, we can see that the prompt asks us to find liters, so we know we're going to use this equality. Now, I could just set it up on my map. And my map would let me know that, hey, you have to do 2 conversions. That is not what I wanted to do. So we are starting with mass. And we are trying to get to volume. Since mass is involved in the problem, I have to find the molar mass of C3H8. So I said earlier, all of my examples were with the RID table. So my real table, I'm going to add up 3 hydrogens, bad misrands, 3 carbons, 8 hydrogens. So no, I did not make up 44.11. I quite literally got it from the periodic table. Now, you could wait until you know you needed that number to do the calculation. If you really, really wanted to, you could show it in the fraction. I wouldn't. I would just do it out to the side somewhere and have that number available to use. So 55.6 grams of C3H8. Since grams is what I'm trying to get rid of, it must go on the bottom. The one flaw to my map is it doesn't remind you that you have to write the thing in the prompt. So you may want to add that as a reminder to start by writing the numbers and the stuff in the problem. But it does do fairly well after that. It tells me that, hey, I'm going from mass to mole, so I must put mass on bottom, mole on top. Again, I could get that from the equalities. I could see that mass has to go on bottom because it's the thing I'm getting rid of. And if mass is on bottom, that is the only thing that can go on top. I'm only allowed to put 1 mole on top if mass is on bottom. So mass means, hey, I got to use that 44.11. So we've got moles. We don't want moles. So we're going to have to do a second conversion. This time, mole goes on bottom. If I was using my map, I would see that, hey, I'm starting on moles and I'm going to volume. So moles would have to go on volume on bottom. Volume would have to go on top. So since I am trying to get volume, I am trying to get liters. I know I've got to use the equality where liters is at the top. Liters is at the top. 22.4 must go with it. Since moles at the bottom, 1 must go with it. In terms of significant figures, we have 3 non-zero numbers. So my answer needs to have 3 non-zero numbers. So handy dandy calculator gives me, I don't think I changed the color, so let's change the color. Gives me 28.23486738. So we know we want to keep not the first 3 numbers. So we look next door at the 4th number, and it's only the 4th number because we're having to keep 3 again. And that's a 4 or less. So that means the 28.2, that 2 lets it rest. It stays the same. Oh. All right, dramatic pause. If you don't have at least 1 example in your notes, you need to get at least 1 example in your notes. It is up to you on to whether or not you are using the mole map, or if you're making your own little fraction cards, that is absolutely fine. Again, you don't necessarily need to use either. You can get everything from the equalities. So I want y'all to give problem number 3 an attempt. Okay. So looking at the prompt, notice the number is with molecules. Molecules is a form of particle. Oh. So you could switch out molecule for particle if you wanted to. I really don't care. I'm fairly confident that the mole map in Google Classroom does have all of them listed. I said fairly confident, so if they're not, let me know. That means I need to update and attach the most current version. But we are starting with particles because it has the number, and it is asking us to find mass. And since the substance doesn't change, we are not crossing the mole ratio bridge. You will learn about that tomorrow. So notice I'm going from myself to the house. That gives me 2 islands, which means this is a 2-fraction conversion. Hence why I call it 2 steps. Even though it takes 2 fractions, the first thing that has to hit the page is the number from the prompt. So 495. Well, why did I say 495? Let's try that again. 4.95 times 10 to the 24th molecules. CO2. I don't know why I made that one C so big, but whatever. So since we are trying to get rid of molecules, it must go on bottom. If molecules is on bottom, that means we've got to put Avogadro's number with it. Incoming email. If molecules is on bottom, that means 1 mole must be on top. So if we look at our units, we can see that molecules cancels and we are left with moles. I don't want moles. So now mole is the thing that I'm trying to get rid of. Moles on bottom. Well, I've got 3 different equalities with moles, so that may not help much. So I'm going to go back and read the problem, and I'm going to see that, hey, it wants mass, which means we're got to use the molar mass one. So mass must come on top. Moles on bottom, well, it's got to be 1 mole according to the equality. Mass is on top, well, it's got to be molar mass. And I don't currently have that number. You may remember it from the previous example because I used the same substance. But if you don't, the molar mass of CO2 was 44.01. We got that by adding up 1 carbon and 2 oxygens. Once you show a molar mass calculation for 1 compound, you do not have to re-show it again for any other problems on that assignment. And yes, there are several times where I reuse the same substance just to make y'all's life a little bit easier. So double check my units. Mole is canceled by mole. We are left with grams, and grams is what it asked for. So that means that conversion is set up correctly. I could have used the map to get to the same place. I started with the puppy, and I went from the puppy to the mole. So particle to mole was the first step. Particle had to go on bottom because that's where I was. Mole had to go on top because that's what I was going to. Once I did the first conversion, I literally moved my little puppy over to Mole Island, and I'm going from mole to mass, trying to get the puppy to the house. Mole goes on bottom because it's the island we are on. Mass goes on top because it's the island we are trying to go to. And picture in your head that this map and these islands are on lava or something. And unless you're on a path, you're not allowed to make that move. So be a little Mario, stay away from lava. All right, handy dandy calculator. Didn't write down all the digits, but notice we started with 3 non-zero numbers. So my answer should have 3 non-zero numbers. 3 significant digits. And I know I'm saying non-zero, but if there's a 0 in a sandwich, it's significant, so it counts as a non-zero. If there's a 0 at the end of the number and after a decimal, it's significant. So it's kind of a non-zero number in that situation. Where'd it go? I don't like yellow. Brown. So I know I'm keeping the first 3 digits. I look at that 4th digit. It's 8. That's a 5 or more. So we raise the score. So it's 362 grams of CO2. So if you are one of my students who did not finish Friday's practice, that really should be first priority after you have answered the opener and uploaded your notes for today. Because Friday are these individual conversions by themselves. If you're having challenges with them by themselves, you're going to have even more challenges with them combined together. We do have 20 minutes left in class. So once you answer today's opener and upload your notes, you're either working on today's practice in Henry Connects, or, and I think most of you fall into this or category, you are finishing up Friday's practice. And yes, make certain as you're doing it, read the extra little comments with the model responses. For Friday's practice, I'm not going to be as detail-minded with the significant figures. So if your answer isn't rounded exactly like mine, it's not a huge deal. But I am wanting you to kind of start thinking about how you should round and try and start rounding appropriately. Ultimately, for my honors babies, when it comes test day, it's 1 point on one problem. So it's not a huge deal. But if you take AP Chem or you take College Chem, you have a better foundation on how to round and how to know how to round.